right, let's go ahead and get started. So we did not cover the empirical rule. It is a extension of Chebyshev's theorem, right? Chebyshev's theorem stated that for a set of observations, the population that lies within k standard deviations, let's write this down just to get it in our notes again, because again, this is a sub version of that. So it's all coming from Chebyshev's theorem. And the empirical rule is going to be on page 84 and 85 of your text. And remember, Chebyshev says for any set of observations, population or sample, the proportion of values that lie is 100%, because everybody lies. No, I'm kidding. Within k standard deviations, is the mean, or sorry, of the mean, is at least 1 minus 1 over k squared, where k is any value greater than 1. So that's Chebyshev's theorem. Now, the empirical rule is stating that when we have a symmetrical bell-shaped frequency distribution, right, which is what we have here. This is a symmetrical bell-shaped frequency distribution, which you will often hear described as a normal curve. So a symmetrical bell-shaped curve or a normal curve is going to have the following characteristics of it. The first one is that when we are looking at the central bit of the data, if it's a normal curve, we know that 68% of all the data is going to fall between these points of 90 and 110. So 68% are going to fall between 90 and 110. Now, how did we come up with this? Well, we were told that, so the information we were told at the beginning here that I should have wrote down, our mu, right, our mean here is equal to 100. And then our standard deviation is equal to 10. So just a very simple kind of situation here, right? 100 is your average, standard deviation is 10. So the empirical rule is telling us that 68% of the values are going to lie between 90, which is the mean, minus 1 times my standard deviation. And then this is going to be my mean plus 1 times my standard deviation. I know it's silly to say 1 times something, right? Because 1 times anything is itself. But the reason why we're doing this will become a little bit more clear in the next step. So the empirical rule is the other side of standard deviation. So it works because of tautology. It works because of how things are defined. So if we have a normal curve, the standard deviation is going to tell us the range. So plus or minus the standard deviation from the mean will tell us the range of 68% of the data. So the next part of it, well, so this is going to be 100 minus 1 times 10, right, which is how we get 90. Just make it very clear. And then this is going to be 100 plus 1 times 10, which is how we get 110, right? No surprises there. let's just move these in a little bit. Come on, dude. You know what I want you to do. Just do it. Okay. The next part of this is this range here. So this range here is going to tell me 95% of all of the data. And the way that we find these values of 80 and 120 is going to be my average minus 2 times my standard deviation. And then this is my average plus 2 times my standard deviation. And then lastly, we have the most comprehensive measure in our empirical rule, which is (130 and 70). And this one has 99.7%. And this we calculate by doing mu minus 3 times my standard deviation. And this is mu plus 3 times my standard deviation. Questions on the empirical rule? So again, it's just a more specific application of Chebyshev's theorem. It is something that is not going to play a lot into the class until the end of the class when we start to talk about regression analysis. And then the empirical rule is going to be something that we're using constantly. So it is something that it's on the midterm. The other thing about the midterm is 2 of you snuck by me and took it before I got a chance to change it. So that means that we already have a little 5-point curve. So the last 2 questions are on Poisson. Don't worry about it. I'm going to give everybody credit for those. So you're going to get to, they're in order also. The test is in order. So it's going to be chapter 1 questions and chapter 2 questions and chapter 3 questions, right? So when you get to those last 2 questions on the Poisson distribution, just don't worry about it. You're going to get, if you get it right, you're going to get the same amount of points if you get it incorrect. So don't waste the time on it. Questions on empirical rule. I'll also give credit for those answers in chapter 3 homework, because I know a lot of you have been doing chapter 3 homework as practice. So, and it's only like 7 questions, so I'll go back and give everybody credit for those as well. So that should help your homework average a little bit. Questions there? All right.